Okay, we're in the home stretch. Now we're trying to work on the game mechanics where it's time to collapse the rows. And I think that what I want to do is implement this in the bottom. And so let's write a test for this thing. Well, no, let's go ahead and write the functions in different pieces and talk about what we're going to need. So I'm going to bring the bottom up, and this is basically... So this is basically the API. I'm going to take a bottom. And then I'm going to return a bottom less the completed rows. So basically what that's going to do is this is going to do a enum.reduce. And we're going to have another function with an API that is going to collapse row. So this is the row that needs to be collapsed, and it's going to take it out of bottom. Okay, so what do we need to solve this problem? Well, the first thing that we need to do is we need to get the row. So the best way to do that is to get a list of all the y's, and then basically we need a function that tells whether a row is complete. So a row is complete. A row of a bottom is complete if so let's take the bottom and then do a map.keys. So now I'm looking only at the keys of it. Is that going to work? Yeah, that's going to work fine. And so now I can say enum.filter, and I can take out, so X, Y, of X and Y, if Y is the same as row. So now I can pipe that to, never can remember what this is. Well, it's enum.count, isn't it? That works fine. So, and I'm going to pipe that to enum.count, and I'm going to compare. So let's do a little bit of, so I think that I can call, so I can say 1, and I think I can call at, so is that equal to, then I can pass, does that work? No, so I'm not going to try to get too fancy. I was going to try to do basically pass it with the kernel function. But I don't think I'm going to do that because I don't remember what the syntax is. So I'm going to say count is equal to that, and I want to see is a count equal to 10. So if the count's equal to 10, that bad boy is complete. So we need to find the complete rows, the complete y's first. And so to do that, we need to find all the y's, and I think that we could do that. Let's find the complete y's first. The complete y's for a bottom. So so we need the complete y's so that we can reduce over them. And so the first thing that I need to do is get all the y's in the whole list and see if they're complete. So I'm going to do enum.map, or I'm going to say bottom map.keys, and then I can do a enum if the first element, well, really the second element, because that's 0 indexed, that's going to be the y. So, and then I can say enum.unique. So now I have the list of all of the rows, and now I just need to check the ones that are complete. So let's filter. So I've got a function, and this is going to give me a y, and I'm going to see if let's call this a row instead. Okay, so so that's pretty good. So let's go ahead and build an intermediate test just to make sure that things are working this far. So I'm going to add this to bottom test. Okay, so let's create a bottom function here, and I'm going to have a complete row, and I'm going to have extras. Okay, and so all I'm going to do is I'm going to say for 1, just complete, or I'm sorry, 1 to 10, because there are 10 elements. And so I'm going to do a map, and that's going to give me an X, and I'm going to return this thing. And so now this is going to be the key, that's going to be the value. I'm going to replace these along the way, but I'm just marking my place. So this is XY, so this is going to be X, and the Y is going to be the complete row, and the value is going to be X complete, the complete row, and a red. I don't really care what color it is, it just needs to be a color. So now I've created those, and I can add in the extras. So I'm going to do it like this. And I can actually add those right there. I might like that a little bit better. Yeah. So I'm going to add those to all of that stuff. And okay. Okay, so for the completed Y's, let's see if we can take the if I can say call bottom, and I want row 20 to be complete, and I'm going to pass in a few extras of 19, 19, and this is going to, and basically I need to dump all of this into map.new. Okay. Yeah, okay. So now I'm going to create a bottom with this row 19, 19, red. Okay, so now I have a bottom. And now I can say So and the complete Ys are, what are we going to have? We're going to have basically just 20, right? That's only completed the completed row. So let's see how that works. I ought to have a few compiler errors. Yeah, I'm not this good. Okay, so there's a lot of warnings that we need to clean up. So the first one is bottom.ex34. Oh, let's call this bottom, and this is bottom, like that. Okay, complete Ys does not exist. Okay, so bottom test is 44. So complete Ys okay, so it looks like our complete Ys works. So now that ought to help us in our quest to actually do some collapsing. So now we know what the complete rows are. So the full collapse is going to take the bottom, and then I'm going to get the complete Ys, and then I'm going to reduce over that. And basically, I'm going to call collapse row, and I want to pass these two arguments, but the accumulator in Elixir is the second argument and not the first. So I'm going to pass that accumulator. So so we try to pass bottom first, just so things are easier to pipe. But this is effectively why this is called reducer. The arguments are just in a different order. So I'm going to reduce over that. And I'm going to start with a like that. So the bottom is my initial accumulator. So now I just need to collapse the row, right? So the first thing that we need to do is so if I know the Ys, the rows, if I want to complete a single one, so actually I'm just completing one of those, aren't I? So if I want to complete a single row, then all I have to do is first drop all the keys. So basically it's going to look like this in pseudocode. Drop all the broken keys, or all the ones that are, and then move bad rows up, right? So maybe I want to def move row up, and that's going to take a key value, and that's going to be of the form XY, and it's really going to be XY color, like that. And we'll list it that way. So we will get in trouble if these aren't the same, but maybe we want to detect that kind of an error earlier. So if we want to move the row up, and basically we want to move it up in respect to the row that's being chomped, right? So we know that everything that is below or has a bigger number of the chomped row is going to be okay. Everything else needs to change. So we're going to say when Y is less than row, we're going to do one thing. And when Y is greater than row, we're going to do another way. So, or this is this a row? Yeah. So that's correct. So basically, this is going to be move bad points up. So this is for all the other ones. Okay. So if y is less than rho, then we have to rewrite this one to something more of our liking. And it's going to look like that. But we're going to basically bump those two down. Right? So that looks good. And otherwise, we're not going to change a thing. So we actually don't need to match all that stuff. So this is the so key value, and we'll call this the key value. Okay, so basically we're going to have to drop the bad keys first. So that's bottom. So that's enum dot drop, and then I think I just need the keys. And does this work with one key? Let's find out. So 2, like that. And then I'm going to do a map.drop. Map.delete. Yeah, so that's it. So I just want to do a map.delete in that. Oh, you know I can drop all the bad keys. All the bad keys at once. And so to find those, all I have to do is bad keys is equal to bottom map.keys .filter, and I'm going to want a function because I'm going to want to compare x, y. So that's the one we want to. So that gives me all the bad keys, and so then I can drop them all at once, and then I can move the bad points up. And so, but this is just moving the bad points up. This is just moving a single bad point up. So what I want to do is enum.map over everything, and I want to call. So I've got bad keys. So this is going to give me you know what? That's already in the right shape, isn't it? This is already in the shape that we need. enum.map, and I could say at move bad point up, and then it's going to be n1, it's going to be a row. Yep, and I can just drop that all into map.new. Okay, so let's see if we can collapse a single row in our test. And remember, this isn't going to work the first time, but we can give it a shot. So okay, so we're going to collapse a single row, and then I'm going to say, so first I'm going to say io.inspect, and then I'm going to collapse a row, and I'm going to pass it a bottom. a new bottom. No, let's just take a bottom and then let's do this the right way. Okay, so now we're going to run a test. Okay, so row is unused. That's in bottom 49. Let's fix that first. That's usually low-lying fruit. That's why I fix them early. And often they'll give us some key value row. Okay, and we just want to ignore this one, right? Okay, undefined function collapse row 2. Okay, let's see, collapse row, bottom row. So that's collapse row 2. So bottom.ex undefined function, single L. Okay. Undefined function collapse row 1. Okay, so I don't think it's that same spelling error. So bottom, okay, so that's the test. And collapse row, okay, so we need to tell it that the broken row is the 21. Okay, beautiful. So I'm actually getting the collapsed row correctly. So now my actual is this guy. Assert actual. I'm going to say something. I'm going to say 19, 19. In actual. And then I'm going to do the same thing with a refute. So refute that 120 is in the actual. Let's try this again. Okay, so this is the eventual one that's failing. So my key is 19 and 20, which I didn't expect at all. So I expected it to eat up all these. Okay, so something is wrong with our collapse row. Okay, so let's start to do our debugging. So our collapse row Okay, so this is the list of keys that we're going to try to drop. 1920. Ah, there you go. So that's a 20. So 10, so 128, 223. Oh, yes. So we were supposed to move this up, and we did. This is working exactly like it's supposed to. My test is just broken. So essentially, I want 1920 to be in the list. And so, and then I want to refute that because that one has been moved down now. And I can say assert equals 1. So let's see if this passes now. Enum count or length. Okay, so now all I need to do is find the other inspect. Okay, it's not in there. There it is right there. Okay. Now is this clean? It looks like that's pretty clean. So the last step for us to do is to go ahead and make the other one pass. And I think I'm going to pick that up in the next lesson. So we have basically 2 more to go. The next one will basically take the code that we've written and merge that into our Tetris API, because we want this to be all simple and clean. And we want to wire that through the Tetris API, this piece right here. So this piece that returns a brick, a bottom, and a score. So this is basically going to have to drop the rows, and it's also going to have to understand how to score that thing. So the last piece of the game then is to integrate those pieces there to actually do the enum reduce. And the last piece is then to plug that into the LiveView game, and then after that we are done. So I estimate that we have 2 more sessions. It's about 10 sessions longer than we expected, but I think it's worth it because we've taken some more advanced directives to make things work. And so we've tried to make it a little bit more educational by adding things like the inspect protocol and other things like the debugging tools for LiveView. Hope you enjoy it. Bye.